Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome lead code problem called detect squares, and we can see that this one is a lead code medium problem and also not very well like problem because it's like quite complicated to understand, but I really found this problem quite fascinating. So let's try to work on this. Basically, we are given a stream of points on an XY or two-dimensional plane, and we need to design an algorithm that basically does two things. First, it adds the new points that we are getting of stream of xy plane data structure in like basically storing them somewhere in a type of data structure, and duplicated endpoints are allowed and they should be treated as different endpoints. So we'll have to keep track of the frequency of any particular endpoint at any given moment. Second thing is, given the query point, we might be needed to implement a method called counts, where we are given a point xy point, where basically we need to determine that out of all the points that we have added so far, based on the given counts point, are we able to generate any squares? And if we can, we need to determine that what are the total number of squares we are able to make using that particular point and all the other previously points that we have received. So basically we need to implement a detect square class, and we need to have two methods in it. First one is add, that basically adds a point, and second one is count, that returns that how many number of squares that we have been able to generate. Now let's try to understand this with an example. Typically, we would be given an input like this, where first we are initializing the detect square class, and then we are adding bunch of the values, and we are also at random instances asking for a count of total number of squares that we have been able to detect, and these are the endpoints that we are adding. So now let's try to see how it looks like visually. So basically in this example, first we initialize this detect squares, then we add three values. So those three values are 1 1 1 3 and 3 1. So they are over here 1 1 1 3 and 3 1, only these three values. Okay, and at the same time we also come up with a count mechanism where we are trying to check that does there exist any square from this 3 1 endpoint. So basically from this particular endpoint, are we able to generate any squares? Now notice that at this moment in this method we only have these 3 points, so we are not able to generate a square at the moment. So we will return 0 for that count method, but subsequently we add one more point, that is this 3 3, and which is defined over here. And after that, once again we ask the same question of generating a count, and to which we can notice that now we are able to generate a square. And a square is simple, that every single edge should have the same length and they should be perpendicular to each other. So in this case, each of this has a length 2 and they are perpendicular to each other like x and y axis. So that's why this is a square that we can form using this 3 1 point. So in this case we would return 1 as the answer. And we could have a case where, let's say, next value we are trying to add is once again 3 3, so we would have one more point over here, and then we are being asked to check that are we able to detect any squares using this 3 1 endpoint. So now in this case we can generate two squares. First square looks like this, and second square looks like the other previous endpoints. So basically in this case we would have returned 2, but you get the point that what we are trying to generate. Now, understanding this problem is actually quite complicated. How do logically we can make the solution work basically? And then we would try to understand that how can we tackle of implementing add method, and how can we tackle implementing the count method in the most efficient manner. Now let's try to visually understand the solution approach. We are given these 4 points. We are trying to determine that how many squares we are able to generate using this 3 1 endpoint. Number one thing that we are going to do is to check that do we have any other points that are common with x endpoint values. So in this case we can find that there exists a value 3 3 that is different from this point, because we also have an endpoint called 3 1 that is currently plotted, but we cannot use the same endpoint in this case. So let's say that we want to find a value that has x but a different y. Okay, so we find a corresponding value 3 3. Now we know that these two are going to be in a straight line. Now if there were to exist another value that can generate a square, basically it has to be of the same edge length as this one. So it has to have the value 2 as the edge length of it. Okay, now we have one of the edges for the square. What would it allow us to generate the square? Number one thing is we can iterate over all the other remaining points and try to see that what are the different points we have and are we able to generate a square from that or not. But in this case, we would have to take a look at all the different 3 remaining sides. That is going to be an expensive operation. Second approach we can do it is that based on these two endpoints, we can determine that what are the endpoints we are going to need, because we already have the distance 2 in order to generate a square. And we know for a fact that if, let's say, that on an empty graph we only have the values 3 3 and 3 1, and we are being told that this is one of the side of your square, then other side of the square has to live somewhere over here or over here, where the distance has to be 2 in either case. And let me explain what I mean, because we can only generate a square like this, or we can generate a square like this, because this is a common edge. This has to live there for sure. And we know that this distance has to be 2 and this distance also has to be 2 in order for a square to exist. So what are the potential endpoints? We know that this is 3 1 and this is 3 3. So if there has to be a square with value 2 possible, then that value is going to be, so this value would have become where we are adding the x coordinate to with value 2. So basically this would have become 5 and 3, and this would have become basically 5 and 1. If let's say we had this endpoint present, we could have generated a square, because notice that the difference would have been 2 on each side and this has to be 2 because of this. Or second option is that we could have on the other side, so that is going to be x minus 2 values for both of them, because y coordinate is going to remain constant because we are aligning our match based on the y coordinate. So this value would become basically 1 and 3, and this value would become 1 and 1. And we know that now we already had one side that was 3 3 and another side that was 3 1. Potential two values we found is either 5 3 and 5 1, or 1 3 and 1 1. So now the thing that we need to do is to check that amongst the added endpoints, do we have either these two entries or these two entries. It's not like if we have 1 3 and 5 3 it would work. No, it would not work. It has to be pair of 1 3 and 1 1, or pair of 5 3 and 5 1. And in this case we know from the input that we have a pair 1 3 and 1 1, and if we are able to find these endpoints, basically we are able to generate a square. So we can just update that value. And it could be possible that if we had this point, let's say 1 3 2 times and 1 1 2 times, then in this case we would have generated 2 multiplied by 2, so in total 4 squares. If we only had this like 2 times and this value maybe just once, so in this case we would have generated 2 multiplied by 1, because of the number of occurrences, only 2 squares. So we will have to keep track of the frequency of endpoint as well, in order to determine that what is going to be the fastest solution. So now let's come back to our original ask. We basically were given a data structure where sequentially we are adding the values. Now in order to add the values, what are the things that we need to take care or we need to understand? Number one, we need a quick way to look up whether any particular x value, x coordinate exists or not. And why are we considering? Same can be said for the y coordinate. I'm just taking x because it logically makes sense. Why? Because remember, in this case we were able to quickly identify this endpoint, and then we wanted to check corresponding values. So corresponding values would have been like 5 3 and 5 1, or 1 1 and 1 3. So in this case we were able to checking based on the x endpoints. That is number one thing. Second thing is we also need to store appropriate y coordinate in accordance with the x coordinate, because there are pairs being present for x y pair. And third thing is, we need to know the frequency of any particular endpoint. So if let's say this 1 3 was present 2 times, I wanted to know this quickly. So what data structure comes to your mind in order to store this information that can fulfill all of this? Number one, if we are trying to store x and y, we could have used something like hash map. But in this case, apart from storing x and y, we also need to store the frequency as well. We can still use hash map, but this is going to be like a slightly complicated hash map, because number one, we are going to have a hash map where we need to have key value pairs. So we are going to have key and value combinations. As key, we would treat the x coordinate values. So let's say that currently first we had the value 1 1, we would have added 1 over here, and as its appropriate value, we are also going to store one more hash map, a mini hash map within hash map, and that too is going to run basically the same way. It is going to have a key vault pair of its own, where the key is going to be the y coordinate. So basically this is going to be value 1, and the value is going to be the frequency of y coordinates occurrence, because we already have the frequency of x coordinates occurrence. We only need to keep track that how many times the same y coordinate occur for the same x coordinate. So in this case, the frequency is also going to be 1 1, so we can store that information. Same way, next coordinate we are adding is going to be 1 3. So once again, the key 1 is going to remain common, but as part of its value, we are going to have one more entry inside this hash map, where now the value of y coordinate is going to be 3, and its frequency is going to be 1. Okay, then we are going to have one more entry where the x coordinate is going to be 3 1. So we are going to have one more entry 3, and as y coordinate, the value is going to be 1 and its frequency is going to be 1. Same way, we have one more value 3 3 in this case. So 3, we already have it as a key, as an input, so we would have stored over here the another value 3, that is the y coordinate, and its frequency as 1. So we are keeping track of frequency at every given instance, and for every single x coordinate, we have the subsequent y coordinates and its frequencies. So it follows both of our desired needs. Now we know how to quickly add a value. If we see time complexity, in this case, this would have run in nearly big of 1 time every time, because based on the x coordinate, we would be able to quickly look up and we would be able to see that what are the corresponding y coordinates in also big of 1 time, because we are using a hash map. In terms of time, like space complexity, this would become an big O of n solution. For every combination of x and y pairs, we would need to add new entries to the hash map. So we can generically just mention that this is going to be big O of n. Okay, this would be our solution for adding method, or to build this data structure. Okay, next portion of the problem is that how do we detect squares? Now notice that for the detect square method, basically we need to generate that what is going to be the count of squares, and we are given an entry point, so an xy coordinate that we are already given. We can treat this xy coordinate as one of our x1 and y1 that we are trying to working with. So we are going to be dealing with an x1 value, and we can quickly check in our hash map that whether we have any other values for this x1 that is currently present within our detect square method. So let's say that we wanted to detect that for this value 3 1, how many number of squares exist. Okay, so in this case, for this 3 1, we know that the x value is 3. So we will come to our hash map and we will see that for this 3, how many corresponding xy values we have. One value we have is going to be 3 and 1, and so this is one value that we currently have present, but because it's the same x and y, we cannot use this endpoint, so we'll just ignore this. Next value we have is 3 3. So next value that is currently present is going to be 3 3, and that is pretty good that we can actually use this. So now we have one endpoint is 3 1, another endpoint is 3 3. So difference between y1 and y2 is going to be 2. Now because we have this value 2, all we need to do is to add 2 to the one side of x and add 2 to the other side of x. So basically we already have this one edge 3 1 and 3 3. So now we will need to determine that plus 2 on the x side, so that is going to be 5 1 and 5 3. Do we have this pair present? And second one is 1 1 and 1 3. Do we have like this combination present? And if either of this combination is present, which again we can quickly look up because we are storing all the information in a hash map, so we can quickly look up whether 5 is present as an input or whether 1 is present as an x coordinate. And if they are present, what are the corresponding y values? We can also take a look at the frequencies, and then we would basically just detect the squares and build the solution. So this is the whole solution. And if we try to understand the time complexity for basically count operation, this is slightly tricky but not that tricky, because we know that we can quickly look up the values of x coordinate for any particular entry in big O of one time. But for that x coordinate, there can be multiple y coordinates. So in the worst case scenario, we might have to iterate over all the possible y coordinates as well. Because imagine, let's say that instead of this being 1 1, what if we have all of these bunch of different endpoints, and even over here we have all of these bunch of different endpoints. For every single pair, we have to keep looking for the combinations of different x and y coordinates. So that would become a hassle. So the time complexity for this count method would be big O of m, where m is the total number of y coordinates present, because in the worst case we might have to iterate over all of them. So that's still relatively a good time and space complexity given how complex this question could have been. So we are trying to use the logic and power of math and some geometry to solve this problem and to not go through the brute force route. So I hope the solution made sense to you. Now let's quickly see the coding approach for this one. So the coding solution is going to be slightly complicated, but let's understand. So first we are initializing a private hash map that we are naming as points count, that we are going to be using to adding all the values. And notice that we have key as an integer and its subsequent value as another hash map. So there is a hash map within an hash map. Okay, then we are going to have a detect square method that is simply going to initialize the hash map, and then we are going to implement the add method. Now in the add method, it's quite straightforward that we are considering the value x as 0.0 and value y as 0.1. For every single x coordinate, we are initializing a new hash map if the x coordinate is not already present. And then for every single y coordinate, we are checking that if it is not present, we basically add the frequency as 1, or if it is present, we basically update the existing frequency. So if it is present like 2 times, we just add it to 3. Okay, now here comes the meat of our problem, that is the count method. Now in the count method, as an input, we are given an endpoint. So we are treating its x and y coordinates as x1 and y1. This would allow us to iterate over all the possible combinations. And we are initializing a variable called total squares that we have found so far as 0. Now the very first thing that we need to check is that does our hash map contains any other value that is on the same x coordinates as the given point x1 coordinate. If we don't have any values, we can directly return 0, that's it. But if we do have bunch of points on the x coordinate, then for each one of them we'll have to do the following, and that is that we would find that what are the subsequent y values. We will also try to see that what has been the frequency of that xy combination. We would check that if the y2 is equal to y1, which means we are at the same point that we are already given, we can ignore that. If that is not the case, we would find that what is going to be the edge length or side length by doing the subtraction of y2 minus y1, and this is going to be an absolute value. So it doesn't matter if it's like above x or below x, overall we are only dealing with positive integer. Then we will have to check that what are the possible values that would allow us to generate basically a square, and then we would add it to the existing list of total squares. And for that we are using a helper method called count squares, where we are taking in x1 and y1 coordinates. We are also taking in x3 and y3 coordinates that we are trying to build, and we have the y2 and the count y2, so frequency of that coordinate. So after having all of this value in the helper method, we simply check that do we have the x3 coordinate that we were talking about and its subsequent y1 value. If we do, what has been the count frequency, and we simply multiply that to basically add the value to our total squares. And we do it for both like x1 plus side length and x1 minus side length. So this would give us both set of endpoints, and in the end we simply return total squares. Now I know the coding solution looks quite long, but if you just go and check it out our GitHub repository, you would find that this is an easier solution to understand once you know that what conceptual solution means. Let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this code. And our code beats 95% of all the other solutions, which is exceptional. And we beat 91% of all the other solutions in terms of time complexity, space complexity as well, which is also quite nice. So this is present in our GitHub repository. And I know that this solution says it's a medium solution, but in my opinion, this can be treated as a hard problem as well, because it's not quite straightforward to understand.